Hi viewers, here we have our 304 stainless steel normally open differential S36 series. So one thing to note when installing it is the direction of flow. This is an arrow cast on the body. Now it's differential, so what does that mean? Well, it means that across the valve you need a differential pressure drop of 0.3 of a bar for the 1-inch model anyway. The larger sizes, the pressure drop is slightly higher. So that really means that between the inlet and the outlet, you need a differential drop. Now, applications where you can use this, where you get it, is usually compressed air, mains water, downstream of a pump, anything like that. Now, situations where you might not get it is tank drain, low head applications, low pressure, vacuum, things like that. This valve, you can't use it for that. It's a 304 stainless steel body, IP65 DIN plug, which goes on here. So you run your wires into there with the appropriate cable gland into the bottom of the DIN plug, and that goes on your coil. Now I'll take it apart just to show you how it works. So I'll just nick this coil off. And what we're left here is the obviously the body of the valve without the coil. Here is the operator stem. Inside there is the armature, and within the valve body itself is the diaphragm. So I'll take the valve body apart to show you how it works. Just loosen these 4 bolts off. Take the top off the valve now. You'll see under here is a spring sitting in this little cavity of the diaphragm. Now this keeps the diaphragm in place and keeps it closed, so it really demonstrates why you need the differential pressure in this valve. Well, you've got to overcome the tension of this spring holding the diaphragm on the seat, so it's not going to work down to a no pressure application, because you won't have any pressure to compress the spring and to push the diaphragm up into the top of the valve, so therefore you won't get any flow. Just on the underside of the roof here is where the diaphragm is pushed into, just a flat surface. We take the diaphragm out, it just pops out. Now you can see in this diaphragm, this little dog ear here is the bleed off gallery. So where it comes from up in the operator stem when that bleeds off downstream. And here you can see the bleed on hole. It's a slightly smaller hole. It's slightly smaller because obviously the pressure that's coming on, or the amount of flow that's coming onto the diaphragm, is less than what's going off. So that's open and just keeps that normally open flow through. One thing to note when maintaining these is to make sure these 2 holes are clear in the diaphragm, and also that this seat in here is clear of any foreign debris. We have a look in the operator of this valve. So here you can see there's 2 holes. There's one hole coming into the side of the operator chamber. That's where the pressure from the top of the diaphragm comes. And there's another hole here, which is the jet. Now that's the seat of the armature sits on that jet. Now it's held up at the moment when there's no power on it by the spring. You can see the spring there. That holds the armature off that jet. So the flow path comes up into here and bleeds off. You've got enough pressure, the diaphragm will stay open. So the spring holds the operator off that seat, and if you have a look at the operator itself, it's made up of 2 parts. Here is a little rubber boot on the bottom. We'll see the O-rings to seal the chamber. And then this is the top half with the shading ring on it. Goes in first, shading ring down, and the operator. Make sure that O-ring sits in there nicely. and then the spring. It all goes back into here.